Okay, moving on from the area of triangles, today we're going to be learning about finding the area of parallelograms. So as a warm-up today, I want to see if you can look at all the words I'm going to put up now and either put into a sentence one or two more of these words, or just make sure you understand the meaning of them. So we've got the words area, perimeter, length, height, width, base, perpendicular and parallel. So see if you understand what those words mean, write them down, try and put them into a sentence, and I'll go over them in a moment. Okay, let's look at some of those words that you were given. Hopefully you will have known most of them. So start with perimeter. Perimeter of a 2D shape is the distance around the outside. So in this rectangle, you would add 4, 3, 4 and 3 to get the perimeter. You'd add 4 and 4 is 8, plus 3, 11, plus 3 is 14. Your perimeter would be 14 metres around the outside of this shape. Area, as we've been learning, is the amount of space that a shape takes up. If we look at the area of a rectilinear shape, which we did a week or so ago, rectilinear, remember, is shapes that come together to form right angles, like this one. If you do the area of a rectilinear shape, the formula is length times width. So in this case, the length 4, the width 3, you would have 4 times 3 equals 12, and we always put area as 2 dimensions, so it's 12 centimetres squared. So area is the space it takes up for a rectilinear shape, shapes that come together to form right angles. We do length times width, 4 times 3 to give us an area of 12 centimetres squared. If we're looking at the words there, base and height and perpendicular, I'm immediately thinking area of triangles that we've been learning. So your base of a triangle and then your height of a triangle makes a right angle. On a right angle triangle, it's always going to be the base and the height. You're always going to have the two sides because you've got the right angle there already, and these make the right angle. So it would be 3 times 4 for your base times your perpendicular height. In other types of triangles, you have to be more careful. If you look at this isosceles triangle, you've got a base of 4, you've got the side here of 5, but you've got the height down the middle here as 4. You know this is the perpendicular height because it creates a right angle here with the base. So your area of this triangle would be 4 times 4 and divided by 2, as we've just recently been doing. 4 times 4, base times height divided by 2. Okay. The other word you had on there that we haven't covered yet is parallel. Parallel lines are lines that keep the same distance apart and they never get any closer together or further away. They never meet. You can have them any direction, going up and down. I always think of train tracks as a good example of parallel lines. You get lots of parallel lines in shapes. Rectangle, you've got parallel lines here and here, showing that they're equal, and a square, and lots of different shapes I'm sure you can come up with which show parallel lines. Okay. Okay, let's have a look at this shape we have now on the screen, this pink shape in the middle. What I would like you to do is describe the properties of this shape. What is special about this shape? Try and use some mathematical language. If you can, try and use some of the language that we have just come across in the previous slide. But describe this shape using mathematical language. See if you can come up with as many things as possible about the properties of this shape. When you've done that, you can resume the video and I will go over them. Okay, so this shape, as you probably know, is called a parallelogram. And the properties, the mathematical definition of this shape is this. It's a flat shape, a 2D shape, with 4 straight sides where the opposite sides are parallel. So in this example, you can see that the opposite sides here are red and blue and blue. So the red sides are parallel, the blue sides are parallel. Also, the opposite sides are equal in length. So again, the red and the red are the same length, the blue and the blue are the same length. The opposite angles are also equal. So angle A and angle A are equal, and angle B and angle B are the same. Okay, so these are the properties. This is what makes your shape a parallelogram. So using that knowledge, I want you to have a look at the shapes on the left-hand side. You've got 6 shapes there, and I want you to have a look now, draw them out, see which fits that description on the right-hand side that we've just been through, and either give a tick or a cross to which ones you believe there are parallelograms. When you've done that, you can resume the video and I will go through the answers to that. Make sure you're using that description on the right-hand side to check if you think they are parallelograms or not. Right, let's look at these shapes and see if we can work out with our properties of the parallelogram which ones are actually parallelograms and which ones are not. So if I start here and using the information I have, let's see if we can check. So 4 straight sides, yes, this one has 4 straight sides. Opposite sides parallel, yeah, this and this are parallel and this are parallel. Opposite sides equal in length, yeah, it's a square, so they're all equal in length, and opposite angles are equal, they're all 90 degrees. So yeah, that is a type of parallelogram. Moving on to the rectangle, 4 straight sides, yes. Opposite sides parallel, yes. Opposite sides equal in length, yes. And opposite angles equal, again, yes. So the rectangle is a type of parallelogram. Now looking here, we've got 4 straight sides, 1, 2, 3, 4, yes. Opposite sides parallel, yeah. Opposite sides equal in length, yes, and opposite angles are equal. So again, that is a parallelogram. Looking here at our rhombus, 4 straight sides, yeah, opposite sides parallel, that is parallel to that is parallel to that, yes. Opposite sides equal in length, they are, and opposite angles are equal. So again, a rhombus is a type of parallelogram. Right, looking at this shape now, 4 straight sides, 1, 2, 3, 4, yes. Opposite sides parallel. Well, that and that are parallel, but is that and that? No. Okay, and opposite angles as well are not equal. So that one is not a parallelogram. And let's look at this one. 4 straight sides, yeah. Opposite sides parallel. No, these two are not parallel, and the opposite angles are not equal here. So these two are not parallelograms. But looking at this, we can see that squares, rectangle, rhombuses are all parallelograms. They're just special types of parallelograms because they have their own unique properties. So we give them their own special names. But in fact, they are all parallelograms. Okay, so now we understand what a parallelogram is. Let's get back to thinking about area. So the space that a parallelogram takes up. So we've got a little task for you to do now. If you have got squared paper, that's brilliant, use that. But if you haven't, you can still do this task. What I'd like you to do is, first of all, if you have got the squared paper, draw this out accurately on it. If not, just have a go at counting from the screen. Roughly, how many squares does that parallelogram take up? So what would be roughly the area of that parallelogram? Okay, when you've done that, if you haven't drawn out a parallelogram, just draw it on a whiteboard or paper. If you have it on your squared paper, great. I want you to draw on the dotted line, which goes from the top to the bottom. It makes a perpendicular line at the bottom there. It makes a right angle at the bottom. Draw that on and then cut along that dotted line. When you've cut along that dotted line, you will have a triangle, okay? Can you then move that triangle to turn that parallelogram into a rectangle? Okay? Have a go at doing that task now, and when you're ready, resume the video, and I'll have a show you of how I did that. Okay, well done if you had a go at that. Okay, well done.
If you drew it out, you might have been able to do something.
If you drew it
like
out,
this.
you might have been able to do something.
You
like
started
this.
with a parallelogram.
So
at the
you
top,
started with a
and
parallelogram.
You were asked
at
to
the top,
cut,
and
this
you were asked to
little
cut
triangle bit off here.
This little
and
triangle
then
bit off
replace it
here,
over here and see what
and
happened.
then
So if you
it
cut
over
off
here and see what
this
happened.
section
so
here,
if you cut
you're
off
left with this
if I
section
imagine
here,
I've cut
left
that
with
off,
this.
if I imagine I've cut
And
that
I'm
off,
left with this now,
and I'm left with
touch this
this
bit
here,
now,
and then
I
I put it
this
over
bit
here, and then I put it over here. So I'm now left with this. So I'm now left with, okay, so I've taken off here and taken off here. What shape
so I've taken
have
off
I
here,
made
taken off here.
by
What shape
taking off
have
I
I made
here and putting
by
it here?
taking off
I've made
a
a triangle
rectangle.
here and putting it here.
So
I haven't added
rectangle.
any more to this.
So
I haven't taken
I haven't
it away.
added
All
any
I've
more
done
to
is
this. I
move
haven't
one
taken
bit
it
of
away.
shape.
All
All
I've
I've
done
done
is
is
move
move
one bit of my
so the amount of
shape from this
space
side to
that it
this
takes
side.
up. So the amount of space that it takes up.
So when you're
is
looking
still
at
exactly
area of
the
parallelograms,
same.
you
So
can
when you're
see
looking
that
at
the
area of
space they take up
parallelograms,
is
you can
exactly
see
the same
the space
here
they
as the
take up
rectangle,
is exactly the
because
same
you've proven
here as the
We've taken a little bit
rectangle,
off
because
and
you've
shifted
proven
it
that.
over.
But
But
take a little bit off
exactly
the same amount of
but
space.
it still
You
takes
just
up
moved it slightly
exactly
from
the
one
same
end
amount of
to
space.
the
You just
other.
moved it slightly
The
from one
parallelogram
end
takes up
to
the same
other.
space as the parallelogram takes up the same space as the rectangle. Okay, so we've just seen that the parallelogram and the rectangle take up the same amount of space. They have the same area. This here as well may show you that a little bit clearer. So the top shape here, it's got a triangle in the middle, but the whole shape is a rectangle. The bottom shape is made up of two triangles and a square, but the whole shape is a parallelogram. As we've learnt, they're both parallelograms, but if we took the top one as a rectangle and the bottom one as a parallelogram. What I want you to look at with these is what's the same about the quadrilaterals, what's different, and what would you do to find out the area of each? Okay, we'll have a discussion of this in a moment, but have a think about those 3 bullet points there. Have a look at the shapes. What's the same? What's different? And what about the area of those shapes? And I'll discuss that with you in a moment. Okay, let's have a look at these 2 shapes that you were given and asked to compare. So first of all, what's the same about them? Well, we can instantly see they both have 4 straight sides. They both have opposite sides, opposite angles that are equal. So they're both types of parallelogram, okay? They are both parallelograms. This one obviously we know is a rectangle, a special type of parallelogram. You're asked then to look at the areas of both these shapes. So the area this one takes up, you could count the squares, 1, 2, 3, 4, 5, 6, 7, 8, but you know a rectilinear shape which has right angles, you can just do length times width. 1, 2, 3, 4 times 2, which would give you 8 centimetres squared for the area of the rectilinear shape. This isn't rectilinear because it doesn't have all right angles. We know this is a parallelogram. So how do we work out the area of a parallelogram? We've already established that it takes up the same amount of space as the rectangle. So we know then that this should be also 8 centimetres squared. If we count our squares, 1, 2, 3, those 2 together 4, 5, 6, 7, those 2 together 8. We can see that that is 8 centimetres squared. We're not always going to have squares to count, so there are other ways to do the area of a parallelogram. I can see on here I've got a square and I've got 2 triangles, so I could maybe work it out. I know how to work out the area of a square, I know how to work out the area of triangles. So I could do 2 times 2 is 4 centimetres squared for my square, my rectilinear shape. I could remember my area of a triangle here and do half base times height, or base times height divided by 2. So this would be 2 times 2, 4 divided by 2 is 2. This triangle is exactly the same. And add them together, 4, 2 and 2 would get you the 8 centimetres squared. But again, it's quite a long process to always do a square, a triangle. We might not always have all the details to do that. So how else do you think, looking at this, might we work out the area of a parallelogram? what do you think a formula might be? It is the same as a rectangle. If you were to take this triangle off here and attach it over here, you would end up with a rectangle again, just removing that from that. So you know it is the same as a rectangle. For a rectangle, we do the length times the width. So what do you think you might do for this? You might do the length. It's not the width. Look, thinking of the triangle, what might this be? Would you do this side, or looking at the rectangle, what would you call this? So have a think, and on the next slide I will give you the area of a formula. But see if you can have a think of what the formula for the area of a parallelogram might be before you move on, and then check if you're correct. Right, so we can say then that to find the area of a parallelogram, we use the formula, the base times the perpendicular height. So like with the triangles, we use the perpendicular height. So in this example on the screen, the base is 9 centimetres and the perpendicular height is 6 centimetres, because those two lines create a right angle that you can see there is joined on. So to work out the area of this parallelogram, you would do 9, the base, times 6, the perpendicular height, and your area would be 54 centimetres squared. The base isn't always going to be at the bottom. These shapes can be turned around, but what you're always looking for is the lines that make that right angle, the perpendicular height to the base. So let's now have a look at these three and see if you can work out the areas here. So you need a base, you need the perpendicular height, which creates that right angle, and you need to do base times the perpendicular height to find the area of these parallelograms. Okay, have a go, pause the video and then resume it, and I'll go through them with you. Okay, now you know that the area for a parallelogram is the base times the perpendicular height. This was just a few for you to have a go at. So in the first one, we've got our base here as 7 centimetres and then our perpendicular height here as 5 centimetres. So we have got 7 times 5 equals 35 centimetres squared would be your answer. For this one, we've got our base here as 19 millimetres, and then our base with makes our perpendicular height here, makes our right angle with the base. So we've got 19 millimetres by 10 millimetres, which is 190 millimetres squared. Don't forget your squared, or you wouldn't maybe get the answer correct, because it wouldn't be without the squared on it. And then the last one, we've got our base at 4 centimetres before here as well, making our perpendicular height 8. 4 times 8 would be 32 centimetres squared. Okay, so now you have the basics of how to work that out. Let's see if we can look at a problem-solving question. So we've got Dexter here, who's had a go at working out the area of the parallelogram, and he's worked out the area of the parallelogram is 84 centimetres squared. What do you think? Is he correct? It says here what mistake has Dexter made, so it appears he isn't correct. He's made a mistake. Can you tell me what mistake Dexter has made and what is the correct area? Remember, looking at the base and the perpendicular height. With this problem-solving question, you are asked to work out the area. Dexter has worked it out as 84 centimetres squared, and we're asked to check if we think Dexter is correct. So we know we need the base times the perpendicular height, and we've got 3 measurements this time, so we have to think carefully. Instantly I can see I've got this line and I've got a right angle. So this is a perpendicular line, it's making a right angle. So this is my perpendicular height here. So I know my height is going to be 4 centimetres. My base makes that right angle. So it's the perpendicular line with this. So this line is my base with my perpendicular height. So my base here is going to be the same as here. So it's 14 times 4. If I multiply those, I get 56 centimetres squared. So I disagree with Dexter, but what actually has Dexter done? Well, Dexter has unfortunately done 14 multiplied by 6. He hasn't realised that this isn't the height
of the parallelogram. This is just the side of the parallelogram. 14 times 4 is 84, so he has done this. If you flip this over, you might be able to see more clearly why Dexter is wrong. I haven't drawn that very well, but imagine that's flipped over and you've got your perpendicular height here of 4 centimetres and your base of 14, and this would be your side here at 6. So you can see maybe clearer there that your height of your parallelogram is 4. It's not 6. 6 is just the length of that side, okay? So whatever way round you have your parallelogram, if you've got a dotted line and you've got a right angle, it's a big clue, okay? That is your perpendicular lines. That is your height, and with your base, it makes the right angle. So you do 14 multiplied by 4. Be careful not to just choose one of the sides. Make sure you're getting the base and the perpendicular height to multiply together.
Okay, I'm going to leave you with this one today to have a look at, and again I'll start with it next time. So we've got Dora and Eva here who are creating a mosaic. So they are filling a sheet of paper this size, 19 by 15, and they're using some tiles for their mosaic. Dora is using tiles that are rectangular, and they're 5 by 3, as you can see, and Eva's tiles are parallelograms, and she has a tile that's 5, and the perpendicular height she's given there is 3. So Dora thinks that she will use fewer tiles because her tiles are bigger. Do you agree? Explain your answer. So essentially here you're going to be working out the area of the 2 tiles. And do you agree with Dora? What do you think? And we'll have a start with that next time. Well done today.